Hey guys, welcome back. Today, let's master Codeforces 1846D-Rudolph and Christmas Tree. Basically, Rudolph drew a Christmas tree and decided to print the picture. However, he runs out of ink, so he wants to calculate how much ink he needs beforehand. The triangles will always be in isosceles triangle, and here is kind of an example of what's going on, right? So the total area is 11 here. You can count them. For me, I'll just look at their output down here, and you can see that there's like this little bit of overlap area, right? Now, the intuition for this question is actually pretty simple, right? We can see right off the bat that all we want to print out is the sum of all the triangles minus the sum of all the overlap. And now you may ask, aren't there cases where you might have multiple overlap? For example, let me just draw out some cases. We have our standard 1 overlap. And in this case, we would simply just sum this triangle, we would calculate the sum of this one triangle, then we would calculate the sum of this one triangle, and then we would remove this area here to find the area, right? Now, we also have cases like, for example, down here, where there's no overlap. Bang, 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 bang. In this case, we would simply just sum this triangle, then sum this triangle, and we're done. And then finally, there are cases where we have like a triple overlap, or even more overlap, depending on how the question is structured, or how the inputs are structured, right? Maybe something like this. Now, what I want y'all to realize from this is this like extra overlap here is actually kind of trivial, because when you're building the triangles, when you're like iterating through, you already account for that in the previous subtraction. So, for example, if we were to look at this, like deconstruct it based on how we would add and subtract areas, let's build the first triangle, build the second triangle. Again, we would sum this, subtract this overlap. So now we kind of have this whole thing that's kind of just done, right? Let me see. Have this whole area that we kind of know, right? And then we mess with the last triangle. Bang. I guess the overlap would like poke kind of into here. So just so y'all can visualize better, let's do something like this. Right, and we would do our calculations as normal. We would area this. Okay, we already have this area, right? This is all solved. And then we would find the area of this, and then we would subtract the overlap here. So the triple overlap case is trivial, as it follows the same solve as our original overlap strategy. Now, y'all might be thinking the intuition, or like the implementation, is actually quite simple to this too, right? Basically, we just one pass through y, which is our given array. I've already taken in the inputs for y'all, so you don't have to watch me do that. And then we just add the area of the new triangle each time, and we subtract the area of the overlap. So let's just calculate a toAdd variable, which, for those of y'all who have taken basic math or like geometry, y'all know how to take the area of a triangle, right? Just base times height divided by 2. For this question, we're given a base of d times h divided by 2. Notice that we don't use the double divide because we can have floating point numbers as our answer. And then we can calculate a toPrint variable. Set that to toAdd, because we're always going to have at least one triangle, right? The bounds y is at least 1. And then we can set a prev variable for the position of the last base. And we'll use that to calculate like our overlap. So now the question is, how do we check between the cases where there are an overlap and there are not an overlap, right? So we're going to iterate through for I in range 1 to n, we're 1 passing through y still. To figure out if there's an overlap or not, we can simply just check if the current base, so like, let's call this base 2, this base 1, the current base 2 minus base 1, if this is less than h again is the height of one of these triangles, then there is an overlap, which means if it's the other way around, we just do nothing, right? So let's check if yi, which is the position of the current base, minus prev, which is the position of our last space, if that is less than h, we need to calculate our overlap. Oh yeah, we can't forget to add the area of our new triangle every time we pass through the array. And so if there's no overlap, we just do nothing. If there is an overlap, we need to calculate the area of our new like tiny overlap triangle, right? We can do this with similar triangles since they're isosceles. However, we need to know either the base of the tiny triangle or the height of the tiny triangle in order to find the other, right? We can find the height of the tiny triangle by simply taking the previous, like base 1, plus our height, so base 1 plus h, then subtracting base 2. And that will give us the height of our tiny triangle. And with similar triangles, we can set up this equation, b h. So b is to h as new b, let's just do nb, is to new height. We're solving for new base here, so our new base is simply just equal to, like, this may be a little bit unfamiliar to y'all, but it's basically the same thing as b over h is equal to nb over nh. And so it's a normal math equation where we solve for nb is equal to new base times this is supposed to be nh. So our new base is equal to base times new height divided by height, right? And then to find the area, we simply do area of a triangle again. So it's just new base times new height divided by 2. All right, let's code that in, because that was kind of a lot, and I'll walk through it step by step. So in order to calculate our new base, it's gonna be base times new height divided by h. So we can just by default put in our base, which is d, times new height. New height is a little bit of a hassle to calculate. Not really, it's just simple math, but this is what it is here, right? So we have our base 1, which is our prev, plus our height, minus our current base, which is y0, or yi, right? And then to finish this off, we just divide by our height, right? H, which is just H over here as well. Now, we can calculate the area of our to subtract. So to print minus equals our new base times our new height, which is all of this. Let's just copy all this. Oh my god. All this, and divide by 2. Now we just need to increment our prev. So prev is equal to yi. And then finally, we print out to print. All right. And that should be the full code to this question. This was my submission. And we run it. Yeah, we get exactly this. The only difference is to print is a float, right? So it's going to have the floating point values. And this one, it's not like exact, but it says for each output, the answer will be considered correct if it's absolute or relative error does not exceed 10 to the negative 6. This won't exceed 10 to the negative 6. So this is a perfectly valid solution, and it works. If y'all like this video, be sure to like and subscribe. I will see y'all guys next time. Bye.